Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Modline Matryoshka by Signe, and here are the rules. We have normal Sudoku rules apply. That is that the digits 1 through 9 must appear once in every row, column, and 3 by 3 box. We have a diagonal rule where the digits 1 through 9 must additionally appear once each along the indicated diagonal. Or another way of putting it is that basically there cannot be repeats along this diagonal. So, and this is partly why I also like using the rule set of for normal Sudoku of fill every cell in the grid with the digits 1 through 9 such that there are no repeats on any row, column, and the indicated diagonal. You could do something like that to just concisely say things all at once. But that's just my preference. So that is how we also have that diagonal rule set. We have modular lines, where any set of 3 adjacent digits along a teal line must have different values modulo 3. In other words, it must contain one digit from the group 147, which is 1 mod 3, one from the group 258, which is 2 mod 3, and the one from the group 369, which is 0 mod 3. So, for example, you could have something like, say, 7, 8, and 3 here, and this would work for this modular, at least this section of the modular line, because we have one digit which is 0 mod 3, which is a 3, one digit that is 1 mod 3, which is a 7, and one digit that's 2 mod 3, which is the 8. And that's an example of how modular lines work. We also have XV sums, where digits separated by an X sum to 10 and digits separated by a V sum to 5. So for example, say this was a 3, then this would have to be 2, because these two digits must add up to 5 because there's a V in between them. And say this was 3, and this would be 7 then, because these two digits must add up to 10 because there's an X between them. And finally, we have Kropki dots, where digits separated by a white dot are consecutive. So say you had a 6 here, then this would force this to be 5 or 7, because those are the only digits which are consecutive with 6. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so for these type of puzzles, particularly when we're not given too much information, I like starting to, especially with the longer lines, choosing one cell and making it just a random color. So we're going to make this orange, blue, and yellow for this triangle here. So we're going to make orange, blue, yellow. So here, these are all distinctly different sets, right? Because you have to have a distinct different set. You have to have one of each of the sets for a modular line for any adjacent 3 digits. Well, what about these 3 cells? We still have the blue, we have the yellow, but we don't have the orange left. So this must be orange. And that works for any type of line where you have 3 cells in a row, which must be part of one set. Or, sorry, which you have to have one of each set for that set of 3 cells. So therefore, with these 3 cells, we're missing a blue, so we have yellow and orange, so this must be blue. And we can keep going along that. This is missing a yellow here, so that's yellow. So every third cell along a a modular line, or any type of line which has this rule set, or this like type of rule set, where you have three adjacent digits must have one from every set. Every third cell is the same set, right? Because you already have two that are the same, and you're dropping one, right? So that one that you're dropping has to be the one that's added, right? So this must be orange. This must be blue. We have yellow, and this must be orange. So blue, yellow, orange, blue, yellow, orange, blue, yellow, orange. Oops, that's not orange. This is orange, and this is blue, yellow, and we get back to orange, right? Now, the interesting part of this is that along row 9 and column 9, we have 3 blues and 3 yellows in row 9, and 3 blues and 3 oranges in column 9. So that means the remaining set left in row 9 has to be yellow. So this is yellow. Sorry, it has to be orange. It's orange there. And this must be yellow in column 9. Okay. In these 3 sets, we know we have 2 yellows and 2 oranges already accounted for. This must be one each unique, so this must be a blue, yellow, orange set, right? Because of the way that the modular lines are set, we have to have one of each set. And that leaves this cell has to be blue, because we already have then 3 yellows and 3 oranges in that box. So this has to be blue, which means this is a yellow-orange combination here. What else do we have? In this set, we know we cannot have... Okay, so if we try to have orange be in either of these cells, the problem is that you'd have 2 oranges in that row, and therefore there would be 4 oranges total in that row, which is not allowed, right? Because if you had 4 oranges, therefore it would be... there's only 3 in each set, right? 1, 4, and 7 belong to 1 mod 3. 2, 5, and 8 belong to 2 mod 3, and 3, 6, 9 belong to 0 mod 3, and there's only 3 in each set. So none of the other of these can be orange, therefore this must be orange here. So every third one is going to be orange here, so that's orange. 1, 2, 3, 1, 2, 3 is orange, and 1, 2, 3 is orange here, right? Well, we know none of these can be orange in this box, and we only have 2 oranges accounted for, so this cannot be yellow, it has to be orange left. So this can't be orange, this is yellow left. In this set, so this, we have to be having 3 of blue and 3 yellows in column 1. And we have to have 3 blues and 3 orange in row 1. Well, what's the only one that doesn't have 3? It's this set here, which is every third cell, right? So therefore these would have to be orange, because if we tried to have blue or yellow there, orange would have 3 in column 1, and that's not allowed. So again, this is orange. These 2 must be orange. Similarly, in row 1, where can we have only 2 yellows? It's only in these 2. So this must be yellow and yellow. That means every third one here is orange. Every third one here is orange. And then we populate that way. Orange, orange, orange. Orange, blank, blank, orange, which gives you orange, blank, blank, orange. So this is yellow, blank, blank, yellow. That leaves this as blue. This is blue. This is blue. This is blue. And then we have yellow. Blue and yellow. Blue, yellow. Blue and yellow. Okay. So we should have similar situations here because we have, it's basically symmetric around this area. That's interesting. So this is blue, yellow, except, yeah, it's basically symmetric around the diagonal. So therefore, this must be blue here. Sorry, here, because this is one of each set. And we have two yellows and oranges in that box. So this is blue. Let's see. We have 3 blues and 3 oranges in row 7, so this can't be blue or orange, it's yellow. That leaves this digit as a blue, because we don't have blue remaining. We have only 2 blues in this lower left-hand box. Same with this. Okay, can we... Orange, orange, orange. We have to have 1 blue in this right central box. It cannot be then both of these cells because those are the same set. So this must be blue here. Therefore, this is yellow. So we have blue, yellow. This must be blue, then yellow. Blue, then yellow, and then blue to make that yellow. So in column 7, we have 3 blues and 3 yellows, so that makes us orange. And we're missing a blue again in this upper right-hand box. So let's see. We have to have 1 each of these cells here, because we have already 1 yellow, blue, orange, and 1 yellow, blue, orange here, which means we have 1 yellow, blue, orange here. That gives us 3 yellows and 3 oranges in the central box, which means we can't have yellow or orange, so this is blue here. So different, different blue, different, different blue, different, different blue, and then different, different blue. We have 3 oranges in column 4 and 3 oranges in column 6, which means that the only one left we can have, a blue in the central box, is here. So that's blue. We have 3 yellows in row 5. This can't be yellow. This is orange, which means every third one is orange. So we have orange, 1, 2, orange, 1, 2. Actually, this is yellow, so it just should be orange, yellow, orange, yellow, orange, yellow, orange already here, and that's yellow. In this left central box, we have to have yellow because we have 2 oranges and 2 blues. Therefore, that makes this orange to make this set of 3 different digits, different sets. We have 3 yellow in column 4 and 3 blue, so this must be orange, which makes this yellow. So these are the way that these cells have to be. We have these digits, yellow and orange, adding up to 10, and they're 2 distinct different sets. So the one set that yellow and orange cannot be then is 2, 5, and 8, right? Because 2 and 8 add up to 10, so it would have to be the same set. And 5 can't add up to a set with another digit to add up to 10. So therefore, the blues are 2, 5, and 8. And the blue V's must specifically be 2. And they must add up with yellow being 3. So this is 2, this is 2. This yellow is 3 then, and 3 here. Where is the 2 then in row 4? Cannot be here because of the 2 in the box, can't be here, so this must be 2. Where is 3 in row 4? Can't be here because of 3 in the box, can't be here because of 3 in the box, so this must be 3 here. So this is 3 and 7 to add up to 10. And we don't know what these are, though. Okay, so we have 3 there. That means we have 3 on... That means the other yellows must be 6 or 9 on that. So this is 6 or 9, this is 6 or 9. Same with this. This is 6 or 9. And 1 and 4. To add up to 10. This is 1 or 4. This must be 1 and 4 then, which makes this 6 and 9. So where is the 3 in this lower left-hand box? It must be here. That leaves that as 3, which eliminates 3 here and 3 here in the central lower central box, which leaves that as a 3 there. Where is 3 then in row 7? Cannot be these two because of 3 in the boxes, so this must be 3. Where does that leave 3 in column 7? Cannot be either of these, so this must be 3 here. That eliminates 3 from being here and here in this upper central box, so 3 must be there. And 3 cannot be here or here because of 3 is in the column there, so this must be 3 there. Okay, we have 3's all done. So the remaining yellows are 6 and 9. Okay. 6 and 9 is only consecutive with 5 and 8 here. So this is 5 or 8. Well, we already knew that, so this is 5 or 8. This is 1 or 4. This can't be 2, 5, 2 here, so this is 5 or 8. We have a 5, 8, 5, 8 pair along the diagonal, which tells us that the remaining blue must be 2. So this is 2. That eliminates 2 in columns 8 and 9, so these can't be 2. So in this lower right-hand box, 2 has to be here. That eliminates 2 from being here and here. So where's the 2 in this lower left-hand box? It must be there. That eliminates 2 from being here and here, so this is 2 here. This is 5 or 8, and this must be consecutive with 4 and 7 there. 2 cannot be here and here in this upper central box because of 2's in the column, so 2 has to be here. That leaves the remaining 2 in box 1 as there. So the remaining blue cells are 5 and 8. Okay, remaining orange cells have to be 1, 4, or 7. And again, this can't be 7 because of 7 in the box. These can't be 7 because of 7 in the row. This can't be 7 because of 7 in the column. This can't be 7. Actually, it could be 7. Oh, hold up. Okay, we have... Oh, no, this couldn't be 7 because of the 3 being there. Right. So this can't be 7 because of 7 in the box. This can't be 7 because of the 3, 7 pairs eliminated because of 3 in the column. So where is the 7 along this diagonal? It must be here. So this is 7, which eliminates 7 in the rest of the box, and rows, and column. Where is the 7 in this right central box? Can't be here or here, so it must be here, which eliminates 7 from being here. So that leaves this as a 7 in this left central box. This can't be 7 here or here. In this lower right-hand box, that leaves a 7 here, which means this can't be 7 here, which leaves this as a 7 here. That eliminates 7 from being here, so this has to be 7 here because of the 1-4 pair in the box. This can't be, this has to be 7. That eliminates 7 from being here, and that leaves this as a 7. Well, these digits can only be 4 and 5. So this is 4, which makes this 1, and this 1, and this 1. This is 5, which makes this 8, which makes this 5, which makes this 8. 8 eliminates 8 here, so it's 5 and 8. 8 eliminates 8 here, so it's 5, which makes this 8, which makes this 5, which makes that 8, which makes that 5, which eliminates 5 here, so it's 8 and 5. Which eliminates 5 here, so it's 8 and 5, which eliminates 5 here, so it's 8 and 5. 5 is only consecutive with 6, so that leaves this as 6. 6 and 9. 6 eliminates 6 here, so it's 9, which makes this 9 and 1. This 1 eliminated 1 here, so it's 4. Which eliminates 4 here, so it's 1 and 4, which eliminates 4 here, so it's 1 and 4, which eliminates 4 here. This 5 eliminates 5 here, so it's 8. 4 eliminates 4 here, so it's 1 and 4, which eliminates 4 here, so this is 1 and 9. 1 eliminates 1 here, so it's 4, which makes that 6. 9 eliminates 9 here, so it's 6. 1 eliminates 1 here, so it's 4. 6 eliminates 6 here. Let's continue with 1 and 4. 4 eliminates 4 here, 1, which makes this 4. Eliminates 1 here, so it's 4. And I think that's all the oranges. So now 6 and 9. 6 eliminates 6 here, so it's 9, which makes this 6. Which makes this 9, which makes this 6, which makes that 9, which makes that 6, which makes that 9, which makes that 6. And this 9 eliminates 9 here, so that's 6 and 9. Now I missed that one. So 6 eliminates 6 here, so we have 9 and 6. And that's a solution. Yeah, fairly straightforward. You just go through the coloring exercise and then you'll be able to solve it pretty easily. So, yeah, fairly nice puzzle. These were definitely restrictive. I don't actually know if we needed this X here. Oh, maybe we did. Yeah, we kind of did. Because we needed the 3 here to eliminate possibilities so that we could get the 7 there. So, yeah, we probably needed those. I didn't really use this very much, I feel, but maybe I did. Never mind. I think I did. Nice little puzzle. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.